Hi, so today we're going to be looking at inverses again and also Cramer's rule. So today we're going to be looking at how can we solve systems of equations by using Cramer's rule. Now we're going to be doing this for only 2 by 2 matrices and 3 by 3 matrices. For inverses, we're going to be just finding those for 2 by 2s. So here's how we use Cramer's rule. It's a method that uses determinants to solve systems of equations that have the same number of equations as variables. Consider a system of 2 linear equations and 2 variables. It would look like this. We've got 2 equations and we have 2 variables, x and y. The coefficients of x and y are called a sub 1, b sub 1, a sub 2, b sub 2. And then the constants on the other side are called c sub 1 and c sub 2. So the solution right here is given as the determinant of the one where we replace the x's with the c's divided by the determinant of the entire left side determinant. Now, sounds a little confusing, but once you see it done, it's not really that difficult. Notice again on the top, we're replacing that row of the a values by the c values. On the bottom, though, we're just using the a sub 1, b sub 1, a sub 2, b sub 2. But on the top, we're replacing that a sub 1, a sub 2 with the constants. Now, this only works if the determinant's not equal to 0. So we have to make sure that that a sub 1, b sub 1, a sub 2, b sub 2, that determinant doesn't equal 0. To solve for y, we use the same thing on the bottom, just the a sub 1, b sub 1, a sub 2, b sub 2. But on the top, we replace that column that has the coefficients of y, we replace them with the constants column. So we just do that. And again, this is going to work as long as that determinant doesn't equal 0. So look one more time at that. So if we're solving for x, the x column gets replaced by the constant column in the numerator. If we're solving for y, the y column is replaced with the constant column in the numerator again. That denominator doesn't change. It's always the coefficients of the x and y. So if the denominator determinant does equal 0 and the numerator determinant does equal 0, we're going to have infinite solutions. If the determinant's 0 and the determinant of the numerator does not equal 0, then there's no solution. So if the bottom is 0 but the top is not for that determinant, no solution. All right. So just reviewing that one more time, that the denominator determinant equals 0 and the numerator determinant is 0. Infinite solutions means there are many, many, many solutions. But if that determinant of the numerator of the denominator is 0, but the numerator is not 0, then there's going to be no solution. And we'll see some examples of that as we go on. All right, so let's solve some systems here. So we're going to use Cramer's rule. So to solve for x, we know that that denominator is just going to be those coefficients of x and y. So it's going to go 4, 2, 3, 1. The numerator, though, instead of using all of those, the coefficients of x get replaced with these constants. So we're going to do 1, 5, and then the y's stay the same, 3, 1. So now we're just going to find those determinants. So to find the determinant of the top, we're just going to do, notice one more time on the top, we replace those x coefficients with 1 and 5. And so now to find that determinant in the numerator, it's 1 minus 15. And the bottom is going to be 4 minus 6. Remember how we find those determinants. So that's going to give us negative 14 over negative 2. And that's going to give us x value of 7. So 7 is going to be the only x that's going to make that work. Well, now we want to find out what is the y value that's going to make it work. So to solve for y, that denominator, that determinant is just going to be those coefficients of x and y, just like always. But that numerator, we're going to keep the x's are going to stay the same. So whatever those x coefficients are, it's just going to be the same thing. But the y's are going to get replaced with the with the constants. So we're going to have 4, 2, but then those y values in that determinant are going to get replaced with 1 and 5. And now it's just a matter of solving this. So we're going to do 20 minus 2 over 4 minus 6. And that's going to give us negative 18 over negative 2. Positive 18 rather, over negative 2. And that's going to give us negative 9. okay? And so that means then that the x and y value that will make this true is 7, -9. So if we plugged in 7 for x and we plugged in -9 for y, we would see that that's going to work. But now I'm going to show you how to solve this by using elimination. So I'm going to eliminate the y's by multiplying the second one by -3 to get the y's to eliminate. We're going to get -2x, 0 equals -14. See how we would still get x equals 7 if we did elimination? So this is just another way of solving a system. And it's just a simpler way if, in some cases. Now, in this case, I think just using elimination was easier. But in a lot of cases, it's just as quick to use Cramer's rule. Okay, so once again, that denominator is always the same. It's just those coefficients of x and y. All right, let's look at the next one. So we're going to solve for x. So that denominator is just going to stay the coefficients of x and y. So we're just going to fill those in. It's going to go right there. It's going to be -1, 3, 2, and 4 are going to go in there. Now, in the numerator, we have to replace those x's with the constants that are on the right. So that x column right there gets replaced with 2 and 6. So we're going to write that down. 2 and 6 for the x's, but the y's are not going to change. See how the y's stay the same, but the x's got replaced with those constants. Okay, so now to find this determinant, we're going to have to go and do our diagonals to find determinants. 8 minus 18 over -4 minus 12, or 6 rather. That's going to give us -10 over -10, and that's going to give us an x value of 1. Okay, so we know what x is. Now, we could find out what y is just by substitution, but we're going to practice Cramer's rule. So Cramer's rule tells us then that if we're going to solve for y, that denominator matrix stays the same. Well, we already found it. There's no sense finding it again. We're just going to copy it down. Now, in the numerator, though, we're going to have to keep that x column the same as it is at the beginning. So that's just going to be the -1 and 2. But that y column has to get replaced. So I'm going to do the -1, and then that becomes a 2, and then that's a 2, and then that's a 6. And so now we're going to go ahead and solve this. So we're going to do -6 minus 4 over, and that's -10 divided by -10. And so in this case, y is 1. And so we have our solution. So if x is 1, y is 1, that's going to make it true. You can just plug it in and even see that it works. -1 plus 3 is 2. All right, so 1, 1 is the solution to that system. Okay, now we're going to get a little more difficult. We're going to solve this system, which has 3 equations and 3 variables. So because of that, we can use Cramer's. Now, in order to use Cramer's, that has to be the case. We have to have the same number of variables as equations. So we look at the coefficients there, and we know if we're going to solve for x, we're going to have to replace that x column with those coefficient values. Okay, you can see how difficult this would be to solve if we didn't use Cramer's rule. We'd have to eliminate the x's, then the y's, then the z's, and it could get pretty difficult to do. It can be done, but it's a lot easier if we use Cramer's rule. So we're going to set that up. We're just going to check one more time what we would do if we were going to solve this by hand. The first step would be to multiply -2 by that second equation. But we're going to use Cramer's. So we're going to set it up. We're going to have that denominator. It's going to just be those coefficients of x and y. So it's going to go 2, 4, 8, 1, 3, 5, and 3, 8, 6. And in the numerator, we have to replace that x column with the coefficients over there on the right. So let's just get those in there. 6, 4, 19. And then the y's are going to stay the same. So they're just going to be the same as the denominator, 4, 3, 8. And then 8, 5, 6 on the z. All right, so now we're going to find this determinant. We're going to just double check and make sure we have it in there correctly. And it looks pretty good. Remember how we do this. We go across those diagonals to find these determinants. So if I'm going to find that numerator determinant, I can do that by hand, but I can also do it on the calculator. So instead of using diagonals, let's just do this on the calculator. Let's get this determinant. So I'm going to go to Edit. I'm going to go to Matrix A. And I'm going to do a 3 by 3 matrix and putting that in. And you should always just double check it. Oops, I have a 9 in there instead of a 19. Change that. That's why you always want to double check it, just to make sure you have the numbers in right. It's really annoying when you do the problem and then you're like, what? This doesn't make sense. Okay, so now we're going to go back to matrix and we're going to go and we're going to put in another matrix, B, because we need to do both of those determinants. So I go down to matrix B. I'm going to edit that. It's a 3 by 3. Putting those numbers in. Okay, now I want to quit. I don't want to clear. I just want to quit. Just double checking. Yep, looks good. So we're going to quit. And now we want to do the determinant of that matrix A divided by that determinant of matrix B. So we're going to go in there. And we're going to go to math. We're going to get that determinant, push enter. And then we're going to go to back to matrix to get the appropriate matrix A. And notice that parenthesis there. We want to go ahead and close that. And then we want to do divided by, and we're going to go back to math and go to determinant, and now we want matrix B. So we got to get that one. Close that parenthesis, and then it gives us our answer. And so 3. And what does that tell us then? Well, that's going to tell us the solution for x. X is 3. All right, so we know what x is. Now we can do the same thing for y. Now, we really wouldn't have to write that denominator down again because we already evaluated it, but since we already have it in our calculator, we're just going to know that we don't have to change it again. We certainly don't have to re-enter it. So now we know that the x and the z column is going to just stay the same as it was. But that y column has to get replaced with the constant values of 6, 4, 19. Okay, so I got that in there. So we already know we have that matrix B, or matrix B in there, which is the denominator one. So we're just going to put in the numerator. We'll put it in the matrix A. Just be real careful putting it in. We'll check it. Okay, looks good. So now we're going to go ahead and we're going to do the determinant of matrix A divided by determinant of matrix B. Now, I already put that in there once. I don't have to go back and do that. I can just arrow up and get that. Watch what I'm going to do. So instead of, I can just do second enter and I can get back that last thing I put in. I could also just arrow up and get it. There's 2 ways of getting it back. But because I changed that matrix A, it's going to give me a different answer based on my new matrix A. And so I get 2. What's that tell us? Well, that's telling us what y is going to equal, right? Okay. Quit out of there. See how if I just keep pushing second enter, I can go way back and I can see everything that I've done today on my calculator. And then eventually it just starts circling back. But I can also arrow up and I can get things. And so just practice doing that with your calculator. It's really a useful tool. So y equals 2. Now, to find z, I can keep going. I'm just going to replace that z column if I want to. Or I could just substitute back in x is 3 and y is 2 into any equation I wanted to figure out what z is. That would work as well. We'll just plug it in there. That looks like the easiest spot. So I'm just solving this. Going to get 5z equals -5, so z is going to be -1. And so now I know what x, y, and z are. That's the only solution that will work, is if x is 3, y is 2, z is -1. That's going to work in every single one of those equations There are other numbers that may work for one equation, but that's the only one that's going to work for all of them. Okay? So that is going to be done. That'll be in the calculator part of your quiz. So we're actually, going to have like a non-calculator and calculator part. So that would be expected to be able to be done just on the calculator part, not by hand because it takes so long. All right, now this next thing, this could be on the non-calculator part of our quiz. So we're going to solve systems using inverses now. So first we're going to write the system of equations as a matrix equation. So if matrix A times x equals b, then x is going to be equal to the inverse of matrix A times b. So that's going to tell us how to solve for those missing values. That's not just going to solve for x, it's going to solve for the matrix that shows x and y. So in that case, x isn't just just an x value, it's the whole matrix. In fact, it's better if those are capital X's to represent a matrix X. And that matrix X we'd be finding would be the one that tells us what X and Y are. So we talked before about we can use our calculator to easily find an inverse, but you should also remember how to find it by hand without. So I'm going to go ahead and find the inverse. So first we're going to write the original matrix, 4, 3, 2, 4. And remember how to find the inverse of this. What we have to do is we have to find the determinant first. So to find the determinant, we're going to have to do the 16 minus 6. And that's going to give us 10. So that's our determinant. Once we have the determinant, then we're going to go ahead and we're going to switch those two. The A and D get switched. The signs get changed on B and C. And then we have to divide through by 10. So once we've done that, then we can go ahead and we know that X, that matrix X that's the solution, is going to be that inverse times that B matrix. And that B matrix is just going to be that constant matrix. So we're going to have 4/10 times negative 3/10. We're just writing down that inverse matrix. And we're going to multiply it by the constant matrix, which is 2, 6. That's the values on the right. So B is going to be 2, 6. And we have to multiply that out. It can be a little challenging to do this, but you guys can handle it. All right, so to find out what this new matrix is, remember how we multiply. That's going to give us negative 8/10, positive 8/10, plus negative 18/10. That goes in that spot. To figure out what goes in that spot, we're going to have to do we're going to have to do negative 4/10 plus 24/10. And now then simplifying that, we're going to get negative 10/10, which is negative 1, and then plus 20/10, which is 2. And so that means that our solution then is going to be x is negative 1 and y is 2. So that's another way to solve the system, and that way is using inverses. So we have all these different ways we can solve systems. We can use substitution, elimination, we can use matrices, we can use inverses, we can use Kramer's rule with matrices, and all of these ways would work. All right, let's take a look at this one. So first we're going to find the inverse. First we're going to find that determinant rather. That determinant is going to be, 20 minus negative 2. And so 20 minus negative 2 is going to give us 22. And so that inverse matrix then, we're going to switch those two spots. So it's going to go 5 and 4. We're going to switch the signs on the B and C. And so that's going to become 2, and that's going to become negative 1. And so now to find that inverse matrix, we have to divide each one of those by 22. And then to find that missing matrix that will tell us what x and y are, We know that that missing matrix then, that matrix X, and we're going to multiply that by that constant matrix on the right of negative 1, 1. And so we're going to multiply that out. So we're going to do our multiplication method where we do rows by columns. We get negative 5 over 22 plus 2 over 22. That's going to represent X. And then we're going to do for Y, that's going to end up being 1 over 22 plus 4 over 22. And so figuring that out, negative 3 over 22 should be what X equals, and Y should be 5 over 22. And so that's going to be easier than using elimination on that problem or substitution or anything because of those answers being fractions. And that wasn't so bad, was it? Now I want to show you how we could check it on our calculator. So the way I can use inverses on my calculator is I can go to matrix, I can go over to edit. It's a 2 by 2 matrix. I'm going to put in the 2 by 2. We're going to put in that 4, negative 2, 1, and 5. We're going to quit. We're going to go back to matrix. We're going to go to edit. Whoops. Oh, went too quick. Go to edit, go down to matrix B. This is going to be a 2 by 1 matrix, and it's going to be negative 1, 1. I'm going to quit and clear the screen, clear anything out that you've got. And so once you have it cleared out, then you're going to go back and you're going to do matrix A, and you want the inverse of that, which is x to the negative 1. And then you want to do times matrix B. So you're going to go back to matrix, get down to matrix B, push enter. There's the answer. It looks really strange, but it's probably equivalent. The easiest way to figure out if it is equivalent to do a math frac. Negative 3 over 22 and 5 over 22. And we solve that system. Okay? So lots of very cool things we can do. We got our matrix by hand. You've got it on the calculator. So we're using matrices to solve systems. Just another really great way to solve systems of equations. If you have any questions, just ask.